In this video we're going to look at pH indicators. There's a variety of pH indicators. We're going to look at a few of them. We're going to describe the effect of acids and alkalis on those indicators. We're also going to look at the link between the pH number, the value, and the concentration of ions in the solution. Let's begin by looking at litmus paper. So first of all, we've got blue litmus paper, and we've also got red litmus paper. So there are two types. As we can see here, the blue litmus paper has turned red in this solution. So by turning red, it's indicating to us that that solution is an acid. In this example, however, the red litmus paper is turning blue, and that colour change to blue means that the solution is an alkaline. This table shows the results for litmus paper. As you can see, a neutral solution, the red litmus paper would stay red and the blue litmus paper would stay blue. So you'd have to actually use two papers in order to detect that you've got a neutral solution. The disadvantage with litmus paper is it doesn't tell us how acidic or how alkali the solution is. In other words, it doesn't tell us how strong or how weak those solutions are. A much better indicator is universal indicator, and that can come on paper and also as a solution. The advantage of using universal indicator is you can tell straight away how strong or how weak the acid or alkali is, or indeed you can also tell if you've got a green pH 7 neutral solution. What's worth remembering is strong acids are already orange colour, but the weaker acids become more yellow. Also worth remembering is that the alkalis, the weak alkalis, are a bluey colour. The stronger alkalis go to a much darker blue to purple colour. Now, two other types of indicator are methyl orange and phenol Phailin. You're more likely to come across these indicators when you do a titration, and as you can see, they're giving different colour changes depending on whether they're acidic or alkaline. So for our second learning outcome, what's the link between the pH number and the concentration of ions? Well, we know that acids are made up of positive hydrogen ions, and the concentration of these ions is high at 0. So the concentration of hydrogen ions increases as we go towards 0. With alkalis, we're talking about hydroxide ions, negatively charged ions, and the concentration of hydroxide ions increases as the pH number increases. So the concentration goes up towards 14 for the hydroxide ions, and the concentration goes up for the hydrogen ions as the pH lowers. So increasingly acidic, increasingly alkali also means an excess of hydroxide ions. For acids, we're having an excess, an increase of hydrogen ions. So in this video, we've looked at how indicators indicate to us whether a substance is acid, alkali or neutral, and we know that that change in colour is due to the concentration of hydrogen and hydroxide ions in the solution.